Okay, hi everyone. Firstly, I just want to let you know that assignment 4 will be due soon. So for my class, Pete's class, and Bill and Rowan's class, the assignment will be due a week from today. So that's May the 6th, next Wednesday. And Ben's class, it'll be due May the 12th, because I think you have another assignment at the moment. So to find the assignment, you just go into Canvas, into the Physical Sciences page, click on Kinematics, and it's there, assignment 4. I'll just press preview so you can see what it'll look like for you. So it's just got the questions. You just write in the answers for part A. For part B, you need to download the assignment, look at the questions for part B, write them down on a piece of pad paper or in a Word document, or however you prefer to do it. Probably pad paper is easier because it's calculations. And then scan it and upload it here in question 8. Now, with the scanning, I recommend just downloading an app like CamScanner or something like that. There's heaps of them on the App Store, so that you just take a photo of the page and it converts it to PDF, and that makes it a lot easier for your teachers to sort of download and print. So please do that assignment. I will write down the due date on the Canvas page somewhere as well. All right, now for this lesson we are looking at vertical motion. Okay, so vertical motion is exactly what it sounds like. It's just up and down motion. So we're using the same equations from last lesson and our SUVAT thing, but we're only considering up and down, no north, south, or forwards and backwards, just up and down. So these has some special rules. We ignore air resistance and frictional forces for these questions generally, unless otherwise stated, as it says there. Acceleration for every single one of these questions is always going to be the same if the question's on Earth, and the acceleration is acceleration due to gravity, which is 9.81. So acceleration for a vertical motion question is always 9.81 meters per second squared downwards, unless you're on the moon or something. Okay, vertical motion is symmetrical. So that means that if you, for example, throw something upwards and you throw it up at, let's say, 10 meters per second, it'll go up, it'll stop here, it'll come back down, and it'll come back down at 10 meters per second down. At the top of its flight, the velocity is 0. So here, velocity is 0 because it's stopped and it's turning around to come back down. However, it still has an acceleration of 9.81 meters per second squared downwards because it's in the process of changing direction and coming back down. So it's still accelerating even though it has a temporary velocity of 0. Okay, so let's go into this first example. A person jumps from a bridge 25 meters above the water. What is the person's initial velocity? So we assume if anything's being dropped or if someone's jumping from something, anything like that, unless stated otherwise, we assume that the initial velocity is 0. So sort of just stepping off the bridge with an initial velocity of 0. So u equals 0 meters per second. How long will it take them to hit the water? So we do this type of question the same way we did them last lesson. So the first thing we do is we choose a direction as positive. So this is all downwards. The person's just going from the bridge straight down into the water. So I'm going to go with down as positive for this one. And then we write out our variables. So SUVAT. Okay, now the bridge is 25 meters above the water, so they end up going 25 meters down, so that's S equals 25. U is 0, V we don't know, acceleration is 9.81, of course, always. and that's positive because we've said down is positive. How long will it take? So we want to know what t is. So which equation do we use? We use the one that doesn't have v in it because we're not interested in v at all. So the one we're going to use that doesn't have v in it is this end one here, s equals ut plus half at squared. Okay. And then we substitute in the numbers. Okay, so we've got, firstly, u is 0. So 0 times t, that's all going to be 0, isn't it? So we can say this whole thing is just going to be 0. So now let's substitute the values into the other parts. So we get 25 equals half times 9.81 t squared. Okay, so I'm going to divide the 25 through by half 9.81 so that I'm just left with t squared. So 25 divided by half 9.81. Sorry, I'm just running out of space a little bit here, but I get 5.1 as my answer there. Okay, but of course that's t squared, and I want to know what t is. So t is going to be the square root of that, which is 2.3 seconds. All right, what is their impact velocity? So their impact velocity is going to be their final velocity that they hit the water with. So I am now looking for v. So I know t now is 2.3. So I can actually use any equation now because I know all the variables except v. So I can't use any equation. I have to use an equation that has v in it. So I've got two options. I've got v equals u plus at, or v squared equals u squared plus 2as. So I just think v equals u plus at is a nice simple one. It's my favourite one because it's the simplest one, so I'm going to use that one. So u was 0, a was 9.81, and t we found was 2.3. And if you put that in your calculator, you'll get 22, and it's velocity, so meters per second, and it's going to be a downwards velocity because we got a positive answer, and down is positive, and it just makes sense that it's a downwards velocity. Okay, let's move to the next question. Okay, a ball is thrown upwards at 15 meters per second. Calculate its initial velocity. I don't know why it says calculate its initial velocity because we really just need to state it. It's given us the initial velocity. It's being thrown upwards at 15 meters per second. So u is 15 meters per second up. Okay, the velocity of the ball at the highest point of motion. Okay, again, we don't need to calculate this one because what happens to the ball at the highest point of motion? It goes up, it gets to the highest point, it stops, then it comes back down. So it has a velocity of 0 at the highest point. Okay? All right, now we need to say the acceleration of the ball just after leaving the thrower's hand. So think about that. What is the acceleration of the ball just after leaving the thrower's hand? Okay, the answer is always 9.81. Okay, the only thing acting on it once it's left the thrower's hand is gravity. So the acceleration it's experiencing is just acceleration due to gravity. So what about the acceleration at the highest point? Exact same. Still, the only thing acting on it is gravity. Okay, the maximum height reached, that one we actually need to calculate. So we're going to need to do the whole process. So part of the process is to define direction as positive. Here we've got up and down motion happening, so I choose which one I want to define as positive. I'm going to choose up as positive just because it makes more sense. Okay, so now we write out our variables. Suvat, maximum height reach, that's what we're trying to find. Initial velocity was 15 up. Final velocity at the maximum height, its height's point, it reaches a velocity of 0. and acceleration is always 9.81, and that's negative because up is positive. T we're not interested in, so we need to use the equation that does not have T in it, which is v squared equals u squared plus 2as. And now we substitute into that formula. So we get 0 squared is 0, equals 15 squared plus 2 lots of negative 9.81 s. Okay, so I'm going to move 15 squared to the other side, which makes it negative, and 15 squared is equal to 225. And then on this side, 2 lots of 9.81 is 2 lots of negative 9.81 is negative 19.62 times s, which is what we're trying to find. So to find s, I can now just divide through by 19.62. Those negatives are going to cancel out, and I get 11.5 metres as the maximum height reached. Okay, next. The time taken to reach the maximum height. So again, I'm using the same SUVAT. We do have S now, it's 11.5. U was 15, V was 0, A was negative 9.81. And again, I can use whichever equation I want, and luckily T is in my favourite equation, V equals U plus AT, so I'm going to use that one. So V equals U plus AT, V is 0, U 15 plus negative 9.81 lots of T. Moving 15 to the left-hand side, I get negative 15 equals negative 9.81 T, and dividing through by 9.81, I get 1.5 seconds. Lovely. Okay, the velocity of the ball as it is caught by the thrower again. So this is the symmetry thing. If it goes up at 15 metres per second, then it's going to come down and at the same point reach 15 metres per second down. So up at 15 metres per second. Was it 15? Yeah. Then it's going to come back down at the same sort of point, it's going to be 15 again. Okay? So that means that the velocity as it's caught by the thrower again is 15 metres per second down. Okay, and I will just pause to pick some questions to do from the book because I forgot to do that. Okay, so the questions are on page 18 and you can have a go at questions 1 through to question 10. Okay, thank you. Bye.